Cool. Well, I guess let's get going. John is from New York. I think I knew that. Maryland. I've been to Maryland once. Had a friend stayed there. Mexico
So we have
City.
many people from Germany this time.
Many people from Germany. A lot of people from Europe. A bunch from the US. That's awesome. Okay. Should we kick it off?
Sure.
Just give me a minute to find my notes. Okay, welcome everybody. Welcome to this GitLab Virtual Meetup. Just before we begin, we just want to let you know that this meetup is recorded and will be published on YouTube. So if you're not comfortable with having your image shared, please turn off your video and keep your microphone off. If you are comfortable with having your face shown, you're welcome to turn on your camera. I think seeing some faces is a nice thing and makes it a bit more personal in these, you know, with this sort of virtual online thing that we're all doing these days. So welcome, my name is Adrian. I'm one of the GitLab heroes alongside Nico. It's an initiative that's led by John. Just a note that there is a code of conduct, which I will be pasting into the chat right now. So please have a quick look at the code of conduct. It will be enforced if there are any breaches of that. So yeah, thank you for joining on this Thursday. It's exciting to be here and to have all these people from around the world. If you've just recently joined and you haven't done so, could you mention your city and country in the chat? It would be nice to see who all is represented here. We're going to be having Nico talk about how containerized pipelines and Kubernetes can boost your CI/CD. Personally, I love CI/CD. I love automation, and I think it's great. Kubernetes is also a fun piece of technology, so personally, I'm quite looking forward to this kind of talk. After the topic, we're going to have some Q&A where we can all get to ask Nico some questions. I'm not too sure how we're going to manage that when we get there, but we'll see. So, you know, ask the questions in the chat, but it would also be nice to have people ask them personally so we can have a face and a voice, but that could get a bit much. So we'll see how that we can do that. Yeah, that's it. So please, if you can, keep on your camera and please stay muted. And you're welcome to share anything in the chat box as we go along with this. And then that's it. Nico, do you want to kick us off?
Sure. So let me share my screen. And I need to push the share button. Okay, so you should see my screen now, hopefully.
Yes, we've got your screen.
Perfect. Okay, yeah, so Adrian also mentioned it. I would like to talk about how containerized pipelines work with Kubernetes and how they can boost your CI/CD pipeline. So some words on my side. I'm Nico Meisenzahl. I'm from Munich, like some people in the call today, pretty cool. I live near Munich. I'm senior cloud and DevOps consultant at White Duck. So White Duck is cloud native application development company, mainly focusing on Azure, but we're doing any kind of cloud native development. Yeah, I'm a GitLab hero, like some others in the call today. I'm Microsoft MVP and Docker community lead. And as I already said, doing stuff around Kubernetes, DevOps, containers, and cloud. So what I would like to talk about today is, first of all, how GitLab and Kubernetes works together and some advantages of using it both together. Then I would like to talk about, kick off the topic containerized pipelines and why you should use them. So the pros and maybe some cons. And then we will show, we have a look how the pipeline workload can be moved to Kubernetes with GitLab CICD. And then last piece, we are talking about containerization all the time. So how we can build container images in a container. So in our Kubernetes environment with the open source tool called Kaniko. I will have some demos. So all of the demos are already available. So if you would like to have a look, while I'm talking, this is URL, but I'm also posting the URL. It's on the last slide again, if you would like to check it out later. Okay, so GitLab and Kubernetes. Yeah, it's a perfect fit. So first of all, you can run your whole GitLab instance on Kubernetes. So if you like to run GitLab Containerized, you can run your whole GitLab environment in Kubernetes and scale it out. You can, of course, run containerized pipelines. This is what I will talk about later in this talk. You can use the monitoring and tracing stack of GitLab, which is completely containerized and based on open source. So you can monitor your deployed applications or build applications which are built with GitLab CICD and monitor them and trace them right out of GitLab based on cloud native and open source tools running in the same Kubernetes cluster. You're building your apps and you're running your GitLab and so on. So it's pretty nice integrated. You can run functions and serverless applications with GitLab and Kubernetes, and you can do some nice stuff like review apps, which allows you to review any kind of changes in a merge request. So every time you're creating a merge request, review apps will create a new instance side by side of your application, and you can review it, check if everything is working, everything is fine, and merge the merge request. A pretty nice feature. On the other hand, you have auto DevOps, which allows you to use a whole CI/CD pipeline with any kind of tests and deployment and so on without coding any single line of your pipeline. So just enable it, and you have a full-blown pipeline for your containerized apps that will be deployed to Kubernetes, that will be tested, and so on. So pretty nice integrations. But this time, we're focusing on the containerized part and why we should do so. So why should we containerize our pipeline? Basically, because of the same reasons we are using containers for our applications. So first of all, we can isolate our pipelines with this. So every pipeline runs within a single container and is so far isolated. So it doesn't matter how many jobs you're running together on one machine, in one Kubernetes cluster, they don't see each other, they're completely isolated. Then of course you can, because of using containers, you can put in all the dependencies you need. So it's just defining the container image, maybe building your own container image, putting all the things into the container image this particular pipeline run needs. So let's say you're building a Node.js application, you're putting in Node in the specific version you like to use it, putting in some other dependencies, and then you can make sure that all the dependencies are met. Doesn't matter on which host the job is actually scheduled. Well, just thinking about, you have multiple hosts where build runners are working on, you might need to install the Node.js version on every machine. Let's say you have 5 machines running. You somehow made a mistake installing Node.js on the third one, and then if the build is running on the third one, it might get an issue, or somehow the application is built differently, is running, behaving different in a production environment, and so on. So with containerized image, you make sure that all these dependencies are met, and yeah, every run pipeline run is looking the same. Then scalability, of course, it's just a container. You can scale out if you would like, and immutability is also pretty nice, and CI/CD jobs. So every job you're starting is running the same, because it's every time a new container instance coming up. So you don't have any things left from the previous run or so on. It's every run is looking the same every time, which is pretty important. And once again, it's in container, so it doesn't matter how the host looks like. Everything is within the container image, it's immutable, and everything's fine. So with this in place, you can really build nearly anything or deploy anything. You just need to put all the dependencies and binaries you need into your image, which you're using for this kind of pipeline job. You can use different images, so every pipeline job can get its own image, and it works with everything. So Node.js, .NET Core, Go, Terraform, Ansible, if you're talking about infrastructure deployments and so on, doesn't matter. You just need to put in the things and dependencies you need into your image. So But how do we run those kind of containerized image? So maybe you can think of just using GitLab CICD, using a bash script or something, and just do a Docker run and run our container and so on. It would work, but it's not so fine. And it's basically because the containers are immutable. So if you have multiple pipeline jobs, you might need to think about caching and artifact management and so on, which gets pretty hard if you're only doing containers, because then every container is looking the same. So basically the pro from the site before, they are mutable, but you end up needing to manage all the caching, all the artifact handling and so on your own. So we'll end up mounting volumes from the file system. Then you have a dependency to a file system of your build node. You cannot scale out anymore. So it's not really pretty nice. And at the moment, we are only talking about build jobs, not about talking containers. So which means you would need to build a container in a container, and then you get the other kind of trouble. So Docker one run would somehow work, but it's not really nice. And yeah, so how do we fix it? Basically, there's a nice GitLab runner, which is aware of Kubernetes, which we can use in this place. So it's called GitLab runner Kubernetes Executor, and it's completely integrates the CI/CD with your Kubernetes cluster. So first of all, the GitLab runner itself is containerized and running in your Kubernetes cluster. So it's just a pod, and I will show you in a second. And then this GitLab Kubernetes runner will then schedule your job images or your job tasks as containers in your Kubernetes cluster. So you're having a pipeline with one job. So then the Kubernetes runner will make sure that a container is created or a pod is created in your Kubernetes cluster, and the job is started. And after the job is done, the pod will get deleted and everything is fine. So it's completely aware of your Kubernetes cluster. With this in place and a Kubernetes cluster which can scale out, you can scale out also your CI/CD pipeline. Doesn't matter at all. You just need to scale out your Kubernetes cluster and everything's fine. So how do we install the GitLab Kubernetes runner? We have different options. We have, let's call it one-click options, or you can just go into your repo in the settings page, Kubernetes page, and install it. I will show you the page in a second. Second option is to use a help chart, which is provided by GitLab, which is somehow a more production-ready deployment, in my opinions, where you have different options and settings you can define. And the third one is a pretty new one. It's an alpha feature, but you can also add 2 lines of code in your pipeline definition and just tell your pipeline, hey, I need the GitLab runner in this environment, and then the pipeline itself will make sure that the GitLab runner is installed somewhere. Of course, in this case, with the GitLab runner, it doesn't work on the same cluster because there is a runner needed to install the runner. But you can just run a Dockerized thing somewhere and then use it afterwards. Anyway, this also works. The CI/CD integration also works with any kind of other managed application, which I will show you in a second. So that's it. We can run our images with the GitLab runner in our cluster. But the GitLab runner Kubernetes Executor is also aware how to work with cloning our repos, how to work with caching and artifact management. So you don't need to think about the stuff. You just need to run to tell the GitLab runner in your pipeline definition, hey, I would like to cache this directory, this file. I would like to upload this artifact somewhere, and the GitLab runner knows how to do it. This is done by adding or automatically adding service containers into your pipeline job. So as I said, the Kubernetes runner will create a pod, and in this pod, it will schedule the container with the image you defined in your pipeline. But it also schedules some other service containers next to your build container. And those are used to manage all this stuff. So actually, your pipeline job, and this is every job, contains of some of multiple stages. So we first of all have the prepare stage, which creates the pod and creates the containers in this pod. So the build container, which is actually that one running the image you define, and the service containers. And then we have a so-called pre-build step, which then clones the repo that the repo files are accessible in your build container, restores cache if you define so, downloads artifacts, and so on. And with this in place, your build container can then start and has everything in place it needs. It has a repo files, caching restored, and artifacts restored. Then you can start your build or deploying it, doesn't matter. And after this, we have a post-build step, which is then actually uploading caches again, uploading artifacts again, and so on. So it's completely handled by GitLab as you know it in a non-containerized, non-Kubernetes environment. Yeah, and of course you have some advanced topics, which I'll also show in a second. So you can define resource limits for those build jobs, which is pretty nice in a containerized Kubernetes environment, that you make sure that the build job does not bother any other kinds of deployments in your cluster. You can define CI services, which allow you to add any kind of dependencies for your build or testing. Let's say you need a database for any kind of testing purpose, you can define those, and they will be containerized and started along. You can define if you have a big cluster on which nodes source workloads should be scheduled, and so on. There are many, many advanced settings which you can use. Yes, so with this, I would like to jump over and show you some stuff. First of all, how does the integration looks in the GitLab UI? So I'm here in a group called GitLab commit demo in the Kubernetes section. You can add a cluster to a group and then use it in multiple projects, or you can also add it to the project itself. Doesn't matter. It looks completely the same. So in this case, I also already added a cluster. But if you do not have any cluster, you can the Kubernetes page and just get the add cluster button here. In my case, I already have one. Which you will need to add the cluster. It's just the API and your credentials, certificates, and so on. So it's pretty basic. Just some clicks and it's configured. You can also create a cluster out of GitLab and the Google Cloud, and so on. So if you created it, you now see the health section, which shouldn't bring any kind of errors. So there was no kind of error, everything fine. We see some basic information. So you see CPU usage, memory usage of your cluster, which is pretty nice insight. This is based on the Prometheus integration, so it's not here out of the box. You need to install Prometheus to get it, but it's also completely managed by GitLab. And then you have this kind of application tab where you can install GitLab managed applications. This is the thing I already talked about all the time. So here you can say, hey, I would like to have, and somewhere I'm blind, where's the, here, I would like to have the GitLab runner, and just click install, and then GitLab will install your the GitLab runner in a Kubernetes environment. Once again, same with Prometheus. For all the metrics, just click install, and it gets installed. You can install Ingress, Cert Manager, Crossplane, and some other stuff. Knative for serverless and functions, and here we also have Elasticsearch Stack for logging and matrix stuff. Here you see once again there's a new update, and I could here click update to update my managed environment in GitLab. And this is all deployed into my Kubernetes cluster and completely managed by GitLab, so it's pretty nice. Then I have some advanced settings, but that doesn't matter at the moment. So this is one option. Just go to the Kubernetes cluster and install your runner. Second one, as I said, the more production one would be using a Helm chart. It's available out there. Just let me paste URL just to make sure. And here it's a Helm chart, so you just need to deploy it on your own. And if you have a quick look in the values file, you're seeing all the settings you can define. So we will not jump in on everything, but you can tell them, hey, I would like to get metrics. You can define the default image of your runner. So the default build image which should be used. You can tell if whether it should schedule privileged pods or unprivileged pods. You can define things like the poll time. Here you can define which caching options for the GitLab cache should be used and so on. Those are the advanced features which you cannot define if you install it with the GitLab UI, and so on. So I have pretty much settings like this in the node selector, tolerations, and so on. You maybe would like to add labels or annotations to your bot, to your pods which get deployed, and so on. So I have pretty advanced settings here. And you can just install it with helm install, and it's ready to go. If you check how it looks from the Kubernetes side, so just get my pods from the GitLab managed namespace, and here we see all the GitLab managed applications. So we have the Elastic Stack, we have Ingress, we have Prometheus, and so on. But we also have our GitLab runner running as pod. And this is the runner which is running and writing to schedule our workload, our pipeline workload. So pretty nice. So we can also scale this one out, run multiple instances, and so on. Okay, good. But so how does a pipeline job image look like? So now where we containerize our pipelines, every pipeline job needs an image, as I already said. And this image needs to contain everything the single pipeline job needs. So it can be binaries, libraries, tools, and so on. Is that the question? Let me just check. Are you using ham 2? Yeah. So there's a question in the chat if it's based on ham 2 or ham 3. At the moment, if you're using the GitLab integrated one, it's still ham 2, but it's a secure Helm setup, so it's totally fine to use it. It's with Tiller, but it's secured. But I think GitLab is already working on moving it to Helm 3.0 pretty soon. I think there's an issue out there. I would need to check it. But this may be Helm 3.0 pretty soon. And if it's an issue for you, you can just install it on your own. Perfect. Yeah, so put everything in your pipeline which you would like to have available in your pipeline job, any kind of binaries, libraries, tools, external dependencies, and so on. And then you should also consider rebuilding those kind of images. I saw it many times, customer sites, that they built their pipeline images 2 years ago and still are using them. So once again, make sure those are somehow up to date, at least for security fixes. Every dependency versions I would pin to make sure that they are the same all the time, but for security fixes, make sure to install them. Yeah, and once again, we are running containers, so those are immutable. If you're running containerized pipelines, you need to make sure that you're using caching. Without caching, you will slow down your pipelines. So make sure you implement the caching options GitLab provides you. Use caching to speed up your builds. There's another question, which version I use. I think at the moment it's in 1.6 Kubernetes version. You tell them you have some issues with 1.8, so maybe we can check afterwards in the question section. Just talk about it. Maybe someone has an idea how to fix it. Okay, so this is how a pipeline image could look like. So it's a pretty simple one. It's based on Alpine, and it's just installing some kind of stuff. In this case, it's just a YAML linter. Installs this binary, and then it's an entry point and then CMD section. So with this image, we only have a YAML linter, and we can lint some YAML. So it's pretty easy, but you can install any kind of things you would like to use. So how does this look like in action? I created a sample repo. Once again, it's pretty basic. It's based on a sample application of us. It's just .NET Core application, and there's a chart which we can use to install it. So pretty simple. And we just have in this repo the integration of the GitHub sample and a pipeline definition file. Now the pipeline is once again pretty easy. We have only one stage. We have some kind of variables, and we have our job, which is part of the one stage we have. So once again, we are telling GitLab to run this on Kubernetes. So it's just done via tag. The Kubernetes tag is the basic tag for the Kubernetes runner, but you can also change it to any other kind. But with this line, you're telling GitLab to schedule this workload onto your Kubernetes cluster. Then, of course, because it's containerized, you need to tell GitLab the image which you would like to use. This is done within the image section. So you can tell, hey, I would like to use an image. You can provide a name. In this case, it's just a variable I'm defining up here. So in this case, we're just using an image from my side, which is just providing the ham CLI. We can override the entry point if we would like. In this case, we're doing so. And then we're just scheduling our script. In this case, once again, pretty easy one. It's just a ham upgrade, doing some installations, and passing a variable. So at the moment, the variable is hello world. So if you check our application, we're seeing hello world, I'm Fred. So this is our company logo. He's called Fred. And now we are just running our pipeline. Sorry, now the Zoom thing is over my browser tab. So if you now schedule a pipeline run and just change the message, the application gets redeployed and you're seeing the new message. So let's do this. Let's go to pipelines, run a new pipeline, run it from master. We put in the message and some kind of new text. And before we run this one, I will go over to my Kubernetes cluster and do a watch on my GitLab managed app workspace, namespace. And here we now should see, when I start the pipeline, should see that the pipeline job gets started, gets triggered. The pipeline job will run, and then the pod gets destroyed. So let's run the pipeline. If we check the logs, we should now see a message that the pod gets triggered. If you go over to the Kubernetes cluster, once again, see the runner pod gets started. We have two containers in this pod. So one is our build container and the service container. It's depending. Now the container is creating, now it's running. So now if we switch back, we should see the output of our pipeline. You see the Helm upgrade. And the job is done. So now we're going back to our Kubernetes cluster and we're seeing that the job, the pod gets terminated. And it's already gone. So we scheduled our pipeline. The Kubernetes runner decided to schedule a pod with our build image, or in this case, deploy image with the service container. The pipeline is run, everything is fine. The pipeline is green and the pod gets deleted. So pretty nice. So just to make sure that it's already also working, let's check our demo app. And now we have, hi GitLab, I'm Fred. So it actually deployed something. Okay, so this said, this is how the GitLab container Kubernetes integration is working. But now we are in a completely containerized world. So how do we build our container images? And maybe not only our application images, perhaps also our pipeline images, because we are now containerized, we're running containerized pipelines, we somehow need our pipeline images built. And so you can, of course, use Docker and Docker. I'm not sure if you're familiar with it. So Docker and Docker is basically the different options to use it, but it's differently, it's basically meaning you're running Docker inside a container. So you're running Docker inside Docker container and doing stuff with it. Different options. Every option is somehow not the best one and has issues. First option is that you expose your Docker socket into your container and then just using your Docker CLI and talking to the Docker socket from your host, which of course works. But with this, you can completely access your host file system, create different containers, doing stuff on your host and so on. So you can nearly do everything if you have access to the Docker socket from inside a container. So it's somehow a security issue. Second option would be to mount the valid Docker directory into the container and work with this. It will work. If you run multiple instances, you will get issues because multiple instances will write to one directory and you will get a complete mess up. Third one is you're actually running the Docker daemon inside a Docker container. So this one is actually running Docker in Docker, but therefore you will need privileged mode to be able to do so. And also privileged mode is not so nice. So if you're talking about you have a Linux machine where you're running your builds, it might be okay with this security issues or these issues at all. Might be okay to use it. But if you're running this kind of stuff in a Kubernetes cluster with completely different workload on the same host, you will get issues. Or you even shouldn't be allowed to do so. You shouldn't be allowed to mount your Docker socket or mount a local volume from a Kubernetes nodes or run a pod in privileged mode. So we'll somehow get issues and can't build your container images. So we need another solution. There are multiple open source projects out there. I will talk about one particular in this talk. I really like it. It's called Kaniko. It's an open source project by Google. And with Kaniko, you are able to build container images in containers or anywhere you would like without the need of any privileges and dependencies. So you just run a container based on the Kaniko image, providing your source code, providing your Docker file, and Kaniko will build it for you and will upload it to a Docker registry without you thinking about any kind of dependencies or privileges outside of this container. So it's pretty easy to use. I will show you examples, just one line or depending on how you build it, 4 lines, 5 lines of code, and you can use it. And once again, we're talking about running things inside a container. So also with Kaniko, you should think about caching to speed up your Docker builds. So it's once again the same thing. Kaniko provides 2 different options. First one is Kaniko can cache the layers, so not the whole image, also all the different layers, and push it into a Docker registry, and then pulls it from there every time Kaniko uses this layer. So it's still not the best options, but it's faster pulling and pushing it instead of rebuilding it all the time. The second option is you can cache your base images. So everything you put in your Docker file in the from part, you can cache this one. And for Kaniko, it needs to, those images need to be on a specific volume or a specific path in the container. And this one could be mounted through a volume and managed through GitLab CICD cache. With those both in place, you can pretty speed up your containerized builds with Kaniko. So this is an example how it can look like. Once again, Kaniko is only a container. So in this case, it's an example with a Kubernetes pod. It will also work with just Docker run, and it also works in GitLab CICD, and we'll have a demo of this in a second. But in this case, it's just a content pod, pretty easy. We're defining a name and we're defining the container specs. In this case, we're telling the container name, we're defining an image. In this case, it's just the Kaniko image with the latest tag. And then we provide some kinds of arguments. So first of all, we need the Docker file. If it's just called Docker file, we can basically skip it because it's the default. We can define a context if we to do so, the base directory you would like to run Kaniko in. and you can define a destination. Destination is also optional. So if you like to just build it and test it and not push it, you can leave this, just skip the destination part, and then you can test the image, but do not push it if you like to. If you like to add multiple tags, you just put in multiple destinations. And then it pushes the tags to the same registry, same name with different tags, but you can also provide different registry, different image name, and so on. So just use multiple destinations for all the examples. And with this, Kaniko is able to build the image. So actually three lines, which could be one, and everything is fine. So how does this look like with GitLab CI/CD? Once again, I have a sample repo. Here we have a Docker file. Once again, pretty basic. This one is basically the Docker file or the container image I used in my first example. So it's just providing Helm CLI. So it's based on a kubectl image of mine, and then just installing Helm, adding Helm as an entry point. And with this, we have a container containing Helm, and we can use the Helm CLI to do our stuff. Of course, we have a GitLab CICD YAML. Once again, easy, just one stage. We have a variable, which I will talk in a second about, and we have our pipeline job. Once again, the Kubernetes tag to tell GitLab to schedule it on our Kubernetes runner. We're defining the image, which is the official Kaniko image, and we're defining a version. In this case, it's the debug tag. And this is needed because in the latest or any other kind of image, Kaniko does not provide any kind of shell. And without a shell, the GitLab runner cannot inject your repo code, cannot inject all the other stuff. So you need to run the debug image, but until some month, I think, Kaniko also provides specific versions for the debug image. So in this case, it's the debug image of latest, but you can also define a specific version, a pinned version with a debug tag. So make sure that you use the debug tag. Then once again, we're overriding the entry point just to give you the whole details. And then we have a before script and a script section. The before script section does only one thing. Because we're running this in GitLab and pushing it also into our registry from our GitLab repo, we need to provide authentication because we need to authenticate to be able to push. This is done by just parsing our CI registry, which is a variable the GitLab runner injects, and then just passing the GitLab job token, which is also a variable which the runner provides you with, and put all the stuff in the Docker configuration of Kaniko. So with this line, you're adding everything Kaniko needs to authenticate against your repo. And then we once again have our script. We're running the Kaniko executor, providing context. Once again, it's a default variable of GitLab, just providing the project directory. We're defining the Docker file, which is Docker file, and we're defining the destination. And in this case, the destination is once again a variable. It's our registry image name, so our registry and the image name of our repo. The file, the image name is Helm, and we're just pushing the latest tag in this example. So just run the pipeline. Once again, we're doing a watch. So the pipeline is running. Oh, yeah, it's already started, already created, and already running. So we can go to the output. Kaniko output is pretty similar to Docker build and so on. So it's just pathing in all the steps, the run command, and so on. So now it's building and installing our Helm CLI, taking a snapshot of the file system, defining the entry point, defining the CMD, and it should be nearly finished. Job is done. So let's jump back to our Kubernetes cluster. The pod is already terminated. So the pod is already done. And now we should get, if we go to package and registry and our container registry, and here's a nice little bug with the new dark UI. So now we see the GitLab commit, our image, our helm chart redefined. And if we exit it, once again, we have a small bug. We see the latest image and it's published 43 seconds ago. So pipeline run, built the image, uploaded it into our registry in GitLab, and everything worked pretty well. Of course, you don't need to use the registry within GitLab. You can also use Docker Hub or any other thing, but it's pretty nice integrated, so why not? Okay, with this, I'm done with my presentation. Once again, slides are available. Once again, the link to our demos. If you have any questions, just contact me on Twitter or somewhere. Let me jump to the Zoom chat for questions. We have many stuff in here. I think we have some kind of answers. Did we already fix the issue with Kubernetes version 1.18? Are there already any help and link? Doesn't look like so. Okay, so no. Would you like to speak up and tell out about the issue with 1.18? Or provide some more details in the comments? Okay. Do you know if GKA running a AWS can be integrated in GitLab or Kubernetes on Alibaba? So you can integrate any kind of Kubernetes cluster. You just need the URL of the API, you need your token, your certificate, and you're fine. So you can integrate any kind of Kubernetes cluster.
There's a question above that one about Helm version 2 versus Helm version 3 and Tiller.
Yeah, I think I already talked about this one. Huh? It doesn't matter. So okay. The integration in GitLab at the moment is based on Helm version 2, but GitLab is working on it to update it to GitLab 3, but it's not a big deal, mainly because it's a secure deployment of Helm 2 with Tiller. So it's pretty okay to use. But anyway, if you have any issues with it, you can just use the Helm chart I shared earlier and install it in your own with Helm 3. Okay, there's a question, but the other tools like Elastic and so on are not integratable. Okay, so I think this is related to the issue with 1.18. Okay, so I'm not sure, one of the GitLabbers in the call, do you have any insights on this issue? I would have to check it, so I do not have a 1.18 cluster at the moment, to be honest.
Yeah, I don't have an answer to that one, so I think we can move on.
Okay, perfect. How does GitLab Kubernetes compares with Jenkins? To be honest, I played with Jenkins one time for the months ago. Cannot tell you any details on this one. Which installation option for the GitLab Runner Kubernetes Executor do you use? Do you usually go for? So it really depends. So in a production environment, I install it with Helm. For demos or just testing purposes, I use the integration in the UI or the new integration with CICD, which is alpha at the moment. Does GitLab have some kind of webhooks that can send me an alert on pipeline fella. I think you can gather this information using the API, and I think you can also integrate webhooks into your pipeline. But I would have to check the details on this one. If someone has details in the call, just let me know. Are there other ways of containerizing the pipelines of Jenkins other than GitLab? Say like in an environment where we have Docker, Kubernetes, and Jenkins? Okay, so I'm not 100% sure about this one. So can you add some more details? I mean, if you have Jenkins and running your pipelines in Jenkins, it somehow doesn't make sense to run it on GitLab. So maybe you can add some more details.
Yeah, I wanted to ask actually, say like we have a very basic environment in our company where the containers are running on Kubernetes cluster, and the continuous integration is being taken care by the Jenkins once the code is committed to the GitHub. So
okay,
say like if I want to introduce GitLab in our environment, so so what all the components will go away from our environment, and or if we don't want to use GitLab, then are there other ways where we can containerize the pipelines of our existing Jenkins?
One second. Do you hear me again? Sorry,
yeah.
Just lost my Bluetooth connections of my AirPods. So of course with GitLab Runner, you can containerize all the stuff. You can also use Jenkins X if you would like to containerize your workload and use Kubernetes, not Jenkins, but Jenkins X. Yeah, and if you use GitLab and move over all your CI/CD configurations, you wouldn't need Jenkins anymore. So I think you need just to decide which one to use. To be honest.
Okay. Yeah. Okay. Thank you.
You're welcome. There's a question related to Selenium tests. I never used that one before. So if anyone knows Selenium, maybe just speak up and answer these questions. Okay, thanks for the link for the webhooks. So we have the link for the webhooks with some more details. Yeah, we have email notification. That one I missed. Thanks, John. Then we have a question related to Google Anthos. I never tried to use GitLab with Anthos, but Anthos is once again just a managed Kubernetes cluster. So it should be pretty fine and should also work. But I never did it before. But it's basically a Kubernetes cluster. So if you have the API URL, if you have your token, your certificates, you can integrate it. Okay. Any further questions? Okay. So we have some minutes left.
Okay, there's more answers to the questions by John. Thank you, John. Okay, we don't have much time left. We were thinking of doing a breakout room, but I think we can skip that because there's only 8 minutes. It's not much time to have a chat. So thank you, Nico, for putting this together and sharing your information with us. We really appreciate it.
You're welcome.
Thanks to everyone on the call who joined. It's great having you all. I think we peaked at about 45 people. I wasn't actually watching the numbers. We're down to 33 now. So it was a great turnout. So thanks everyone.
And great questions. Thank you for the engagement. You know, that's a big part of the community, you know, that we're trying to build, is where everyone can contribute. And so your questions and the folks that were responding to those questions in the chat, thanks for that.
Cool. Thanks, John. Just a bit more in closing, if anybody has something that they want to speak about or would like to host or something or send a topic, there's an email address, evangelist@gitlab.com. I assume that goes straight to John, and he can potentially look at running another one of these things, although he is on 10 days of some vacation, I think, so he might not reply immediately.
But you mentioned that his inbox is totally empty yesterday, so just send in mails.
Yeah, I was at Inbox 0 yesterday. We are no longer there.
Okay. Cool. Thanks, everyone. I think that's going to be the end. Thanks again, Nico and John, for making it happen.
Fantastic.
Thanks, everyone, for attending.
Thanks, everyone. And one last thing, I promised to plug this, but we are doing a conference, a virtual conference next month, August 26th. It's free to attend. It's 24 hours. So regardless of your time zone, there'll be, content that you can enjoy, and all the speakers will be doing Q&A following their sessions. So I would highly encourage you to check that out, and hopefully, keep coming to the meetups, and I'd love for you to stay engaged with the community.
Cool. I've put a link to the conference in the chat if you want to grab that before leaving the call.